Chapter 11, Section 2 in the 8th grade note-taking guide is entitled Solving Multi-Step Equations. So we spent some time yesterday working on simplifying the equations. Now we're going to work on actually solving the equations. And as you heard me say yesterday, a lot of this is going to be review. We've been solving equations for the better part of 2 years here. You've done this over and over and over again. You're not really going to hear anything new. It might just be review of some things that maybe we just haven't done in a while. So let's look at the first question. 8x plus 6 plus 3x minus 2 equals 37. All right, so what they're going to do first is simplify what they can. You know that there are variable terms we can put together here, and there are constants we can put together here, just like we did yesterday in 11.1. So the first thing what they're going to do is they're going to go ahead and put the 8x and the 3x together. And they're going to do exactly what it says. Since it says 8x plus 3x, they're going to put that together and write 11x. Then they're going to do the same thing with the numbers here, and they're going to do the 6 and the minus 2 part. And when I put the 6 minus 2 together, that's going to go ahead and make 4. So I've got 11x, and then the 4 equals 37. Let's continue from there. All right, at this point now, we would use the rules we've been using for solving equations forever. All right, our rules tell us to keep the variables on the left. So that means x is going to stay over here on the left, and we're going to send lonesome numbers off to the right. We do have one already over there, 37. So that means I have to move the 11, and I have to move the 4, because all the numbers have to go over to the right side. Now, as far as moving the numbers goes, hopefully you remember that the thing that's directly connected to the variable always goes last. So the 11 is going to go last, which means the 4 has to go first. Another reminder here as far as moving things goes. As far as moving these components goes here, we always do the opposite. Whenever I move something to the opposite side of the equal sign, I do the opposite. So 4 is going to go first, and as far as moving 4 goes, since it's got an addition sign in front of it, I'm going to go ahead and subtract 4 from both sides, and that's what I'm doing first. So I knock 4 off both sides, and I have 11x equals 33. Let's continue from there. This is now a multiplication equation, a one-step equation. You all know the solution in your head, so you can already all figure out how to get there, but we know the rule anyway. This is multiplication, so we're going to divide because that's the opposite. So we're dividing both sides by 11 here. 33 divided by 11 changes into 3. Right, we can check our answer by coming back up here and changing x into 3 and making sure that the left side equals the right side. 8 times 3 is 24. Plus 6, plus 3 times what we now know is 3, so 9, minus the 2. That's 30, 39, minus 2 is 37. Since the other side says 37, the whole thing checks. Obviously, there's no shortage of work to do here, though. You can't really skip any work here, because if you skip work, chances are you're going to miss some important pieces along the way here. All right, let's go ahead and continue on here with example 2. Now, in example 2, they've got some fractions here, which is bad news for us. But what they've done is something we haven't done in a while. They're showing us how to eliminate those fractions, which is a very good idea. So we've got 7x plus 9, 7x over 9 plus x plus 2 minus 17 over 9 equals 2/3. So the first thing they're going to do here is they're going to go ahead and get a common denominator, or at least figure out what the common denominator is here. So if we've got 9 and 2 and 3, the smallest number that I can make 9 and 2 and 3 into is going to be 18. So that means we're getting common denominator here of 18. So if I do that, that means with this first and third fractions, I'd be doubling them. Since the bottom is already 9, and we know that 9 times 2 is 18, I'm doubling those fractions. Remember, when I double them, I have to multiply both the numerator and the denominator by 2. So that's going to change into 14x over 18. And fraction 3 there is going to change into 34 over 18. Now, looking at the fraction at the end here, since the denominator is 3, to change that into 18, I'm multiplying by 6, of course. So I'm going to go ahead and multiply the top by 6 as well. 2 times 6 is going to change into 12. So that's 12 over 18. All right, and then the only thing I got to fix is fraction number 2. Since the denominator there is 2, that means I'd have to multiply it by 9, because 2 times 9 is 18. And remember, you have to do the same thing to the top as well. So that's going to give me 9x over 18. Now, you might be saying, well, wait a minute, that looks a little bit different than what they're doing. You're right, it does look a little bit different, but in a minute I'm going to make it look exactly the same. What you do once you have a common denominator is you go ahead and multiply the entire equation by whatever that denominator is. So since all the bottoms here are 18, I'm going to multiply the whole thing by 18. What that does is it cancels this 18 out with all of those denominators. And it leaves me 14x plus 9x minus 34 equals 12, which is what you see right here on this line of work. Now, what they did here is the exact same thing. All right, notice that they too multiplied by 18 all the way across. The only thing is they did not spend the time getting the common denominator. You can do that, it's not a problem. The only thing is it's harder for some people to see the canceling out because it just doesn't cancel out the bottoms. You actually have to think about your multiplications and see which way it works. It doesn't matter to me which way you do it, whether you multiply individually by 18 or get a common denominator and then just cancel them out. It'll work either way. Well, now that I have 14x plus 9x minus 34 equals 12, life is pretty good here. All right, I'm going to go ahead and put this 14x and 9x together here. That's going to give me 23x's. And then I still got this minus 34 equals 12. All right, well, let's use our rules here. Our rules tell us to keep variables on the left and numbers off to the right. So I know I have to move 23 and 34. As far as moving 23 and 34 goes, remember, we're going to do the opposite. That's always how I move something to the other side of the equal sign. The opposite side of the equal sign is I do the opposite. We also know, because we just talked about it, that the thing that's directly connected to the variable is always last to go. So as far as which one do I move first, 23 or 34, since 23 is connected to the variable he's going last, that means 34 is going first. So I'm adding 34 to both sides. 34 plus 12 is going to change into 46. So I've got 23x equals 46. And then I'm dividing out here by 23 on both sides, and I end up with x equals 2. You can come up over here now and change x into 2 and make sure this works. Now you're saying, well, that doesn't look like it's going to be a lot of fun. You're right, it's not going to be a lot of fun, but it will work. If I change x into 2 here, this is going to be 14 ninths. This one is going to change into 2 over 2, or 1. That's not bad. Minus the 17 ninths has to equal 2/3. Of course, these last two don't have any x's in it, so I don't have to fix anything there. Well, 14 ninths minus the 17 ninths, that's going to give me, in this case, negative 3 ninths. Or if I write it with the 1 in front, 1 minus 3 ninths, or 1 minus 1/3. Well, if I take 1 and subtract 1/3, of course, I end up with 2/3. So it's perfect. The left side does equal the right side. Not as much fun to check, but it did work. All right, let's go ahead and keep going here and take a look at number 3. It says on Monday, David rides his bicycle M miles in 2 hours. On Tuesday, he rides 3 times as far in 5 hours. If his average speed for 2 days is 12 miles an hour, how far did he ride on Monday? Rounding our answer to the nearest tenth of a mile if we need to. All right, so as you can see, they've set this up for us. They said that the total distance divided by the total time equals speed. All right, you know that's formula has always worked for us. Distance divided by time equals my rate of speed. So he rides M miles on Monday and then 3 times as far on Tuesday. So if it was M on Monday, it's going to be 3 times M on Tuesday, which is where this M plus 3M came from. As far as the time, it says he rode 2 hours on Monday and 5 hours on Tuesday. So that's where the 5 plus 2 came from. And it equals my speed, which is 12 miles an hour, or 12. Well, we can simplify that. As you can see, that gives me 4m over 7 equals 12. Now, this is good review for us because this is one that you can solve it like a proportion, and that's exactly what they're doing here. You could solve it really either one of these ways here. What a lot of us would do is we're going to go ahead and put this 12 over 1 and then cross multiply. So when I do that, that's going to give me 4m times 1, which is 4m, and 12 times 7, which is going to give me 84. Now you're saying, well, that looks a little bit different. Why did they do it a little bit different? Don't worry. Realize what they wrote here. 4m equals 84. What do we have here? 4m equals 84. It's the same thing. It's just a little bit of a different approach. What they did here is they just said, well, this is just a division problem. Do the opposite. Multiply. And that works. But, of course, either way, it's the same amount of work to come up with 4m equals 84. All right, so we finished 4m equals 84. Well, we're going to keep that variable on the left and numbers on the right, so we know we've got to move the 4 here. As far as moving the 4, since this is a multiplication equation, we're going to move 4 by dividing. I'm going to go ahead and divide both sides by 4 here. And when I take 84 and divide by 4, I end up with 21. So on Monday, he must have ridden 21 miles. And again, we can check that. We can change m into 21, make sure the left side equals the right side. It'll check just like the last two questions have. All right, so let's go ahead and take a look at the concluding examples here. Number 1, we've got 9x plus 5 plus 4x minus 2 equals 42. All right, so we've got to combine like terms here on the left side before we can do anything. This is more a review of what we did yesterday again than it is so much about today. We're going to go ahead and put the 9x and the 4x together. Since they both have x in them, we can just run them together. So if I have 9 x's and then I give you 4 more x's, I end up with 13 x's. And then I've got this 5 minus 2 here. We can simplify that 5 minus 2, and of course that's going to change into 3. And that whole thing is going to equal 42. Okay, so we're going to go ahead and keep that variable on the left and lonesome numbers on the right. So we got to move the 13 and we got to move the 3 here. We can do that. Which one do I move first? Well, we know the thing with the variable goes last, which means 3 goes last, which means 13 has to go, or 13 goes last because it's with the variable. So 3 is going to go first. Remember, whenever I want to move something to the opposite side of the equal sign, which I do, whenever I want to move something to the opposite side of the equal sign, I do the opposite. So to start off, I'm going to subtract 3, subtracting being the opposite since there's this big old addition sign in front of here. That's going to give me 13x equals 39. And then this is a simple one-step multiplication equation, the opposite being dividing. So I'm going to divide across by 13 here. 39 divided by 13 is, of course, 3. So x must equal 3. We can check it. 9 times 3 is 27, plus 5, plus 4 times 3 is 12, minus 2 equals 42. And, of course, we can simplify that down. 27 plus 5 is 32, plus 12 is 44, minus 2 is 42. Since the other side says 42, it all checks out fine. All right, another fraction question. As you saw with the fraction questions, that means common denominators here is where we have to go. So we'll go ahead and spend time doing that. We've got 5x plus 9 plus x over 3 minus 13 over 9 equals a third. Of course, that means I'm multiplying by 9 here because I can change 9 and 3 both into 9. I've got two fractions here that are already over 9, so I'm going to stay those the same. So that's going to be 5x over 9 still, and that's going to be 13 over 9 still. But these other two guys, to make them over 9, means we're going to have to multiply by 3. All right, so as far as multiplying this by 3 goes, I've got 3 times x, 3x, and the bottom's changing into 9. That's the point. Over here, to change that, 3 times 1 is 3, and 3 times 3 is 9. And now that I've got common denominators, I'm going to multiply the whole line by 9, which is, of course, going to cancel all those denominators out with the 9 that we multiplied by. And that will leave me 5x plus 3x minus 13 equals 3. All right, well, let's simplify this here. We've got 5x plus 3x. That's going to go together to make 8x's. So I've got 8x minus 13 equals 3. And then I'm going to send that 13 over to the other side because we know the 8 and the 13, both being numbers, have to go to the right side. We know that the thing with the variable goes last, which means 8 being directly connected to x is going to go last, which means 13 is going to have to go first. So, send the 13 over. It's going to give me 18x equals 16, and all of a sudden this should be looking a lot nicer to you because now it's a multiplication equation. To solve with division by dividing by 8, 16 divided by 8 gives me 2. So x must equal 2.